So 2-3, what was the word of the day? There was one new point. What was 2-3 about?
Absolute value.
Absolute value. So if you fill in the blank on one with absolute value, you are in good shape. We'll do some absolute value problems here on the board in just a minute to gear you up for what the homework is like. The homework's going to be on 28. Don't celebrate when I say that the numbers are 1 to 5, because a lot of them, if I remember right, 1 has like A, B, C, D, E and stuff. So it's not like 5 of these. Like this might all be like number 1. That might like all be like number 2. But there's like groupings of the questions. But the homework will be 28, 1 to 5. This should help you fairly well prep for the 28, 1 to 5, what that's going to be about. But yeah, 1 was absolute value. When we step into tomorrow, the note that I'm going to put in the upper right-hand corner replaces our fill in the blank. So I will say to you, do a definition for the absolute value of X, and everything that I write in that corner in a couple minutes, that's what you'll want to write on the quiz tomorrow for the 2-4 quiz. Reading 2-4 is going to have 3 new points. When you go to read 2-4, it should be fairly obvious where you're going to find the information that you need, I think. What you're going to have in reading 2-4 is your first postulate of the year. I don't know if you noticed, they slipped in a couple theorems in the other reading. I didn't really mention them because they aren't important theorems for the year. They appeared for a day and just fade. They didn't even make the quiz. We'll never make a quiz, in fact, or a test. But the theorem, the postulate tonight, postulate number 1, appears. That will make the quiz. So when a postulate appears, it's generally good to know the name of the postulate and then the sentence for the postulate. A lot of the sentences, I'll just have you state postulates during the course of the year, like your Bible teacher might ask you to recite John 3:16. For God so loved the world, like you could do that, right? So if I say, hey, tell me what postulate 1 was called, or hey, tell me what postulate 1 the sentence is, that's usually how the questions go. If your postulate is like 1 sentence, I usually just make you say the sentence. If the postulate is like a paragraph, I'll usually resort to fill-ins or something. So if you're ever reading a postulate and it's like this big and you're thinking, is he going to make me recite this whole paragraph? Probably not. Okay. But 2-4 reading, for sure you'll encounter a postulate, know the name, know the sentence for it, and you'd be fine. Then there's 2 other fill-in-the-blank questions, but there's only 3 total points on 2-4. So postulate for a point, one way or another, 2 fill-in-the-blank questions from other stuff that you'll encounter, and that's what that quiz does. Compared to today's, I'm going to do the exact same 6 properties that I did today. The exact 6 ways we did them. Today was a little bit of a mystery. You didn't know what I was going to ask you, whether I was going to ask you associative or commutative or what I asked. The 6 I asked today, I will re-ask those 6. If you want to pick your quiz up later in the day and see how you did, I could get it back to you once I have it graded. But the same 6 properties make it. Number 8 stays the same, 9 stays the same, 10 stays the same, 11, 12, 13, 14, that all stays the same. So compared to today, basically, long story short, everything stayed the same except for number 1 becomes corner in a second, and then there's 3 points from the reading. So, question about what you're looking to study for 2-4 tomorrow, along with our metric quiz, friend. Okay, well, let's do some mathy stuff with absolute values. One way you could explain the absolute value, well, you tell me. What's one way you could explain absolute value to a stranger who never heard of absolute value before?
Makes stuff positive.
Makes everything positive is almost true. Who do we discriminate against when we say it has to make stuff positive? 0. You can do an absolute value and get 0, and 0 isn't positive, but that's unlikely. But yeah, for the most part, absolute value makes things positive. That works for me. What's another way you could explain absolute value to a stranger?
If something's on the left side of the number line, you're going to the right side?
That's fine. That would work. That works for me.
Get rid of all the signs.
just ditch all the signs completely. That works for me. You could also say it's the distance measured from who? Zero. And if you measure a distance from 0, that's all ways you could explain the absolute value to somebody. Every book does it with crazy symbols, because math books like to talk to you in crazy symbols. So here's the note that I said would make the quiz, and this is in the book as well. Absolute value, there's 2 ways that this could go. If I ask you to do the absolute value of one kind of number, you would do one thing. If I ask you to do the absolute value of another kind of number, you do another thing. Does anybody understand and can explain what I'm talking about? How does absolute value have sort of a bipolar sort of thing going on?
If it's positive, it stays positive.
That's correct. So if we do the absolute value of a positive, we just get that number back exactly as it is. And how could we do a definition of positive? This was actually a homework question sometime this week. One of the days that asked you to do a definition for what positive meant.
You make it a number, if we're talking about the number's negative, then make it.
Well, we're doing right now, just can anybody describe what it means for a number to be positive? Greater than 0. So if x is more than 0, we're just going to leave it alone. Just essentially drop the bars. So let me take a stroll leftward. If I ask you to do the absolute value of positive 2, just yell, it's 2. Okay, so anytime you do an absolute value of a positive, just drop the bars. And that's what this is telling you just with symbols. This is saying if you do the absolute value of a number, just give me back the number with dead bars if that number is more than 0. If that number is negative, in other words, less than 0, what do you have to do? Drop the sign. Okay, so if I ask you to do the absolute value of -2, that makes it 2. How could you express with like a math symbol-y thing that the sign just got swapped on us?
Multiplied by -1.
Yeah, so like -x could work. If they give you a negative, just switch the sign. When you see a negative in front of a variable, that doesn't mean it's making the number negative. That means it's switching its sign. If it already was positive, this would make it negative. But if this were negative, that makes it positive. This just means we're switching signs of things. This is almost perfect. We didn't cover every scenario though. We're doing one thing if x is more than 0. We're doing another thing if x is less than 0. What did we forget about?
If x is 0.
If x itself is 0. If x itself is 0, do you leave it alone or do you have to switch around? You leave it alone. How can we like include that in the leave it alone level?
Greater than or equal to 0.
Greater than or equal to 0. And now that's perfect. That's in your book, it's in every book. That's the definition that books just do for absolute value. If we go to do absolute value of a number again, this just means drop the bars if the x is more than 0 or equal 0. Switch the sign if the x is less than 0, and now we're gold, and that's the undescribed question from a minute ago from the quiz. Something there. Answer here? -2. When the negative slips outside the bars, you're going to worry about that last. The bars are like parentheses, by which I mean you have to do them
In order.
first. Okay, bars take top priority. So this means keep us 2, then the negative could stash on. A lot of your math career, you've seen minus minus makes plus kind of things. Does that work in an absolute value setting, or do the bars get in the way? Bars get in the way. The bars have to act like parentheses to act first. If you just saw this a minute ago, that made the problem be 2. Now that takes action, and grand total is -2. Something about those, just with basic number? Then math comes to play. So if the bars take action on those first, because they're like parentheses, they act first, and then you save the subtract for later, because it's not in the bars, what would this turn out to be?
-4.
It would be -4. The bars would keep this 3, the bars would keep this 7. Subtracting 3 minus 7 has to go negative to get -4. Question about that? If I change this, it's changed the problem. Has it changed the value of the answer? No. because this is still zapped into 3. This is still zapped to be 7. It's still 3 minus 7. It's still the same path. How about if I do that? Does that change anything? No, because it's still, immediately the bars change them to 3s and 7s, and then you do the math. Question about that? This one, are you doing the subtract first or the bars first? You do the subtract. The bars have surrounded the subtract, so like parentheses, you have to do what's in there first. So at first, this math makes you think of negative 4. When the bars take action, it is 4. Question about that. If I do this, is that still 4, or have I changed things? I slipped a negative in front of that 3. Is that still a 4 answer?
Yes.
No. Why no?
Because negative 3 minus 7 isn't 4.
Okay, if we do negative 3 minus 7, like number line, start with negative 3, go down 7 more. Where are we going to land for the subtraction of negative 3 minus 7?
Negative 10.
We're all the way down to negative 10 now. And when the bars zap that, we're at 10. Something about that. Let me make another change. I throw another negative there. Are we working 4s? Are we working 10s? Are we working something else? Now where do we stand? We're at 4. Now the old minus minus makes us add rule pops in on these. If negative 3 adds 7, that's 4. The bars would keep it 4. Question about the different ins and outs of that. So this one, a thought, is 10. This becomes instantly 3. This becomes instantly 7. The add is on hold until we made those changes. Add it up, it would be 10. Question about that? Still 10? Something new. Still 10. Still 10? Something new. Still 10. When the bars surround the individual numbers, there's no really changing it by me. We're just sort of stuck with 10s. This, we'd have to do the add first, then hit it. So if you do the add first, who do you think of? Negative 10. Final answer? 10. Question about that? If I make this change, still 10? No. When the bars surround math, it's very changeable. Now when we add these, what does the adding make? Negative 4. Final answer? 4. Question there. What if I do that? We're back to 10 again. What if I just did that? We're back to 4 again. That's why some of the homeworks have like an ABCD. They're going to take like a family of problem and just like make you do all the variations of it. Something there. Solving this for x. What would you do to go about solving that for x? Subtract the 2. So the bars are completely alone, and we'd have 5. So what is the final answer? Both 5 and negative 5. Either of those would work because the bars for 5 makes it stay 5. The bars for negative 5 makes it 5 also. There's a double answer for that. If you want to write it like this, these two answers mean the same thing. If the bars surround just the letter, get that alone. It's going to be positive and negative version of itself. That isn't going to happen here. This is going to have 2 answers, but it's going to be 2 completely different numbers. Does anybody remember how to attack this? Matthew?
Well, it's 2 or, I just say the answer.
2 is an answer, yes.
It's 2 or negative 8, right?
That is correct. How could you get there?
You should probably do this because we do it weird around.
Okay, that's fine.
You make it like x plus 3
gonna split this problem up into two. Absolute value problems have sometimes this like dual identity thing going. Use the x plus 3, but twice. In one world, let it equal 5, like we can see. In the other world, let it equal negative 5, because absolute value gives it that dual positive, negative, possible nature. And then solving this got us the 2 a second ago. And then if we do this one, we get the negative 8 out of that. But just tear it into 2 pieces and solve each piece. Question about that? I know we did this in the algebras. I don't know if our book will do this to you or not. What if there were a negative number over here? You can't even do it. Okay? The bars can only equal 0 or positives, most likely positives. If they ever set you up with bars equaling negatives, it has no solution. The empty set symbol can work there. That's the way that would proceed. And that's what I've got. Unless you have questions, I'll do some more. Anybody confusion on any of that? So again, homework that builds off of that is 28. There's a 1 to 5, pretty well, I think, illustrated by what we did up there. It should be the same kinds of stuff. 2-4 quiz had 3 points a read and then repeat of the other 14, with that one exception from the corner. Metric quiz is from the meetings. Anything there?